Hello friend, welcome to Dr. Subhash Technical Campus. Myself, Professor Chetan B. Bambrolia. Today's lecture topic is Thyristor Commutation method or turn-off method of thyristor. Now in this video, we will see the basic concept of turn-off method of SCR. Now let's begin. Now first of all, let me understand the term commutation. It is the process of turning off an SCR is called, means whenever once SCR is on but it not directly become off, we have to off, and for that we require one another circuit is known as commutation circuit. Now it is achieved by reducing anode current below holding current, make anode negative with respect to cathode. Means in previous video we have seen the characteristic of SCR. In this characteristic we have seen two type of current. The first current is latching current and next current is holding current. Here whenever we talk about the turn on method, at that time we have to consider the latching current, but in turn off method the holding current is most important, because our anode current become less than holding current, then SCR become automatically off. So here we have to reduce our anode current using commutation circuit. Now the two type of commutation circuit is available. The first is natural commutation and second one is forced commutation. Now its name indicate natural commutation or line commutation, means there is no requirement of any extra circuit, because in this waveform the anode current is automatically become 0 or less than holding current, so SCR become automatic off. So the natural or line commutation is nothing but related to AC signal. Means in AC signal there is a positive half cycle and next is negative half cycle. Whenever our current go from positive half cycle to negative half cycle, at that time anode current become 0, then its flow in negative direction. So there is no requirement of extra circuit. But the second type, in forced commutation, is required the circuitry, extra circuitry. So here we have to force to reduce the anode to cathode current, so it is known as forced commutation. So let's start with detail these two type of commutation circuit. Now first of all we start the forced commutation, then next one we discuss about the natural commutation. Here only one type of natural commutation is available, but the forced commutation is many type and we have divided in different class. Here forced commutation is nothing but whenever we want to whenever we use our SCR with DC supply, at that time it is a constant current and there is no any reduction of current, so we have to force our current to reduce below the holding current. But in natural commutation or line commutation there is a AC input signal, so it automatically become positive, then 0, then negative, then further positive. So it is periodically change our signal from positive to negative. So there is no requirement of any extra circuit. Now let's see about the different type of turn off method. Here only name you have to remember. First of all you have to remember the name and with respect to the class. The SCR turn off method is also known as commutation method. The first commutation is class A commutation, and class A commutation is also known as self commutation by resonating the load. Here the name indicate self commutation, means here some resonating device is required, and resonating device is nothing but some inductor and capacitor is connected so that our current should be reduced or become 0. So class A Then class B commutation is also known as self commutation by an LC circuit. Here LC circuit is nothing but inductor capacitor combination circuit. So we can charging and discharging of inductor and capacitor, the current can be reduced. Now in class B we discuss about the LC circuit. Then third one is class C commutation. Class C commutation is nothing but complementary commutation, or is also known as switching a charged capacitor by a load carrying SCR. Means here one another complementary commutation SCR is required, and according to our requirement we can turn off the SCR, that we discuss in next slide. Now fourth, class D communication means class D commutation is auxiliary commutation and auxiliary SCR switching a charge capacitor. Means here you have to use one extra in thyristor or SCR. So main and auxiliary two type SCR is connected in circuit, so we can on and off the next SCR. So this one is about the class D, that is also discussed in next slide. Then class 5, class E commutation, external pulse commutation. Here you have to consider the pulse. Now pulse is nothing but short duration of signal, that is we have to give to the cathode and we have to reduce the anode to cathode current, so SCR become off. That will discuss in class E commutation. And last one is class F commutation. Here class F commutation is most important, because up to class A, class B, class C and class D, and last one is class E, this 5 type of commutation is used in DC source or DC supply. But number 6, class F commutation is only used for whenever we connect our SCR with AC signal. So it also known as AC line commutation, because our supply or operating voltage is AC, alternating current, means it change the periodically our according to the frequency. Now basic difference between AC and DC. DC there is no F, means no frequency. In AC some frequency is proportional or some frequency is available. In this slide the different type of commutation method is there. Now let's start with one by one, so we can easily understand the commutation method. Now first one is class A commutation method by resonating the load. Here in this figure we can see the different in this figure you can see the different SCR, inductor L, resistor RL and capacitor C. Here this one is the DC input signal. Here always you have to connect DC, because in DC only the requirement of commutation circuit. Whenever SCR become on, whenever we give some triggering pulse to the gate and SCR become on, at that time anode to, this is anode, this is the cathode. Anode to cathode current is flow. This current is known as ID current, and if we want to reduce the ID current, ID means ID current, anode to cathode current or anode current is different or reduced, it become below the holding current, then SCR become automatically off. Whenever the current is flow through the inductor, this is the resonating circuit or LC circuit. We can say that load with series or load with parallel. The two type of circuit is available. This is the load parallel with capacitor and this is the load series with capacitor. We can connect this type of circuit. Here simply it is RLC circuit. Now if you want to see the waveform of this figure, then you can refer the different book is available, and in book there is a different waveform is given, so you can understand the this properly. Class A self commutation by the resonating load. This one is about class A. Then class B commutation or self commutation by LC circuit. Here you connect the LC circuit to the parallel of the SCRT. here this one is SCR, and also here connect the DC supply to the SCR, and the RL is nothing but load. Whenever we connect LC circuit to the parallel to the SCR, then it become self commutation by LC circuit. The name indicate LC is nothing but you have to connect L and C, means inductor and capacitor parallel to the thyristor. The waveform related is given here. Here Ig is nothing but the gate current, then IL is nothing but the load current, and current in SCR and voltage in SCR is given to the. Now this type of waveform you have to draw in all type of commutation circuit. So we can understand the value of voltage and current. Now class C commutation is complementary commutation or switch a charge capacitor by load carrying SCR. Here you see the load R1, and this one here two SCR is required. One is main SCR and another is additional or complementary SCR. Means if you want to turn off this SCR, then this T2 means this additional one SCR is required, and this is used to turn off the T1. Means here the charging and discharging of this capacitor C, we can directly turn off the SCR T1. So this one is about the class C commutation, and here R1 and R2, this is R1 is load resistor, R2 is simply path resistor, and this capacitor is used to charging and discharging, and T1 and T2 both, one is main SCR and another is additional or complementary SCR. So it is known as complementary SCR or complementary commutation circuit. Now class D communication, auxiliary commutation. Here an auxiliary SCR switching a charge capacitor, means here also one auxiliary main or auxiliary. Here D means this is the diode, two terminal device, anode and cathode. Anode is connected to here, cathode is connected to here. DC supply, then capacitor, then this SCR T1 and this SCR to T2, and this is the load resistance. The current flow through the RL is known as IL, load current. So this one is about the class D commutation. Here one auxiliary SCR is required to charging and discharging of, here also the one capacitor and inductor. Friends, you have to remember, without LC circuit we cannot design any commutation circuit. So inductor and capacitor is required to design a different commutation circuit. So the charging and discharging of inductor and capacitor, you have to remember the commutation circuit. So different commutation, class A, class B, class D and class C. Now next one is class E commutation, external pulse commutation. Friends, this type of commutation is very different because here you have to use pulse transformer. This pulse transformer is nothing but it is a one type of coupler, isolator. We can say that electrical isolator, because here the same number of primary and secondary number of turn, the turn of this inductor is same, primary as well as secondary. Here one pulse generator, this pulse generator will generate the short duration of pulse, and this pulse is given to the cathode. This is the cathode of SCR. Here no requirement of inductor directly, but you have to connect the pulse transformer. Transformer is nothing but the two winding is connected, primary as well as secondary. Now if you want to turn on this SCR T1, then first of all you have to give the Ig1. This is the Ig1, and Ig1 is nothing but gate current at G1. So this type of pulse is given to the Ig1. At that time, what happened? Whenever we give Ig1, then T2, T1, this T1 is suppose is on, then the current will flow from this anode to cathode through the primary of this pulse transformer. Whenever we give some external pulse, then due to this pulse, the current of anode, this cathode current or this current will reduce. Whenever in figure we can see that whenever we give some pulse, then what happened? Our current become below the this line, means here suppose di by dt rating, then what happen whenever we change whenever we give the ep means pulse, then at this point our current will reduce and it become, whenever it become below the holding current. Some holding current is nothing but the minimum current required to turn off the SCR or turn on the remain on the SCR. It is holding current. Below holding current our SCR become off. So whenever we give some this type of pulse, then our holding current is reduced, and due to reduction of our holding current, this flow of this current become 0. So SCR become off. Here this capacitor, this resistor, all are the circuit element to maintain the SCR become on and off. To limit this current, this RL is required, and according to the charging and discharging, this capacitor will fully charge as well as fully discharge. So this type of waveform you have to remember. In waveform, first of all you have to start from Ig1, then Et1, then Ep, then It. Ig1 is a gate current or gate pulse, then Et1 is a voltage of T1 or thyristor 1, then Ep is nothing but voltage of pulse, and It is nothing but the thyristor current. Here di by dt rating, you have to remember this type of notch is due to the di by dt rating of the SCR. So this one is about the external pulse commutation. Here the name external indicate you have to give external pulse to the cathode, not directly gate. Gate is a this is the turn on method, means some pulse is required to turn on the SCR on the gate, but whenever we apply some pulse to the cathode, then it is reduced our anode current or cathode current below the holding current, so SCR become off. So this one is about class E or external commutation method. So friends, you can take a screenshot of whole slide, then you can directly draw this type of waveform as well as this type of circuit in your notebook. In any presentation slide there is no given of waveform, then you can find it online as well as in power electronics book, so you can easily understand. Or in book very much type of calculation is given, but you have to remember the main equation for the charging and discharging of inductor. So this one is about class E or external commutation circuit. Now next one is class F or line commutation. Friends, this one is most important and very different from the class A to class E. This one is class F. Here one circuit is given. Here the waveform or supply is AC supply. So this is the symbol of AC supply. Then this is the SCR that you have to turn off or in circuit. Then this is the RL. Here simply circuit is given SCR with one resistor connected to the AC load. Now friends, we remember or we already know this one is gate pulse and this is the AC signal. AC signal is nothing but it perfect sine wave, means it contains some frequency. Whenever some frequency added, then positive half cycle as well as negative half cycle is there, means periodic wave. This type of waveform is known as periodical waveform, and according to the positive half cycle and negative half cycle, here Vs indicate up to Vs, this type of waveform is positive half cycle, and 0 to this waveform is negative half cycle. Means whenever we give some pulse to the SCR, then SCR become on. Here you have set the firing angle 0, means whenever this waveform is start, at that time we give some pulse, so SCR become on up to this positive half cycle. But whenever our waveform will cut this line, this origin line, then our voltage become or current become positive to negative, means it achieve 0 level. At this 0 point, our our holding current IH current is below the 0 or it becomes 0, means our anode current become or our anode current is less than the holding current, so SCR become off, automatically off. So this one is a negative half cycle, and negative half cycle, in this negative half cycle our SCR is in off state. But if we not give any get pulse further, then SCR remain off state. So friends, this waveform is simply like as half wave rectifier, means only positive half cycle is cut and negative half cycle is not available in this waveform. So we can say that this is the half wave rectifier using the SCR. So if you want to conduct our SCR in negative half cycle, it is not possible, because we have to here change the direction of this SCR, so we can conduct in negative half cycle. This is the simply line commutation, or we can say that natural commutation, because here naturally SCR become off. We have we cannot or we not require any extra circuit or any force to the externals from the external supply. So natural or line commutation is a class F. Then SCR commutation technique, in which a thyristor is turned off due to natural current 0 and voltage reversal after every half cycle. Means we can say that every half cycle there is a negative half cycle, positive, negative, positive, negative. This is the train of waveform, and in negative half cycle this SCR become automatically off. So we not required any external or extra force to the commutation or any extra circuit. So friend, this one is about the class A, class B, class C, class D and class F commutation. This type of question asked in the MCQ exam as well as the main exam of the GTU or any competition competitive exam. So you have to remember that this class F, this only commutation method that is used in class F, that is only used in AC source supply. So up to class A to class E is used for DC, and class F is only used for the AC. Now you already remember AC and DC. AC supply is nothing but there is some frequency, means some frequency is available. DC is nothing but frequency is equal to 0. So it whenever we draw the waveform, then DC frequency is straight line, or 0 frequency signal is known as DC. But in AC, some frequency in between 0 to infinite, some frequency is available, so it known as AC signal, alternating current. So this one is about all the classification and different commutation. So you have to remember this type of circuitry for the exam purpose. Okay, thank you. You have any doubt or any question, you can then you can directly write on this my email ID chetanb@drsubhashtech.edu.in. We will meet in next video. Thank you.